In this video, we are going to discuss solving a two-step. Sorry, trying to get my computer where it needs to be. So in solving a two-step, we call it a two-step because we have two operations that we have to undo. In this case, we have to undo addition and undo the multiplication in order to isolate the variable and get it by itself. So we have to do both of them. Now, the question often comes up as to, well, which one do you do first? Well, you have to undo the addition first and undo the multiplication second. Why? Because we follow order of operations, parentheses, exponents, multiplication and division, addition and subtraction when doing a problem. When you are solving an equation, you are technically undoing a problem. You are working backwards and trying to find what x originally would have been in order to do the order of operations and get 19. So because we are undoing the problem, we need to work backwards in the order of operations. So you do order of operations in reverse when solving an equation. I always say if addition is the last thing you do, it's the first thing you undo. So we do the order of operations in reverse. So again, I draw my balance scale. Now, I have to undo the addition first, and my inverse operation of addition is subtraction. So I am going to start by subtracting 7 from each side. So again, the rules are I need to make sure to use the inverse and balance my scale. My inverse operation is the subtraction. Now that will zero out. This side, 19 minus 7 is equal to 12. Okay? Now on this side, I can't just drop the x. I am not at the point where I have just the variable. What I have left is 3x. So I need to drop that entire term of 3x. I'm not done like I would have been in the one-step addition. Now I need to undo the multiplication. Again, the inverse operation of multiplication is division. So I will divide by 3. I'm using the inverse. I'm going to make sure to balance my scale and divide that side by 3. Again, the multiplication and division cancel each other out. At this point, I have just my variable, which is what I wanted. 12 divided by 3 is 4. So I have come up with x equals 4. Again, you need to make sure that you're not skipping that step of checking your answer. So I plug 4 back in. 3 times 4 plus 7. 3 times 4 is 12. 12 plus 7 is 19. So this does, in fact, check. All right, let's do another one. This one's going to have some division and subtraction in it. X minus 5, x divided by 5 minus 1 equals 3. Again, this is a two-step because I have two operations. This time my operations are subtraction and division. Again, I think order of operations in reverse. So I have to undo the subtraction first, the division second. I'm still going to use the inverse and balance the scale, and at the very, very end, check my answer. So the inverse of subtraction is addition, so I'm going to start by adding 1 to each side. Again, that zeroes out, and I am left with x divided by 5 on this side. On this side, 3 plus 1 equals 4. Now I have to undo the division. The inverse of division is multiplication. So I will multiply by 5 and balance my scale. Here, the multiplication and division of 5 cancel out to give me just my variable, and 4 times 5 is 20. I have come up with 20 as my answer. And again, I will check my answer. 20 divided by 5 is 4. 4 minus 1 is 3. So this does check. So all that a two-step is doing is taking what I learned about one-step addition, taking what I learned about one-step multiplication and division, and putting them together. The biggest thing that you have to remember when solving a two-step or eventually a three-step or more type equation is you always follow the order of operations in reverse. If you follow this rule, you can solve any equation that is larger than a one-step at any time, and then make sure in the solving process you use the inverse and balance the scale until you get the variable isolated, and at that point, you always check your answer.